Hello everyone. So today we will be discussing PYQ sessions, PYQs of aldehydes, ketones, carboxylic acids as well as amines chapter. It means I will be considering all the important aspects or important concepts of organic chemistry, okay, and particularly from aldehydes, ketones, carboxylic acid, then next from amines, okay, right. So if you have watched the previous live sessions where I have covered all the class 11th and class 12th organic topics, okay, right. So here the first question is from amines. Yesterday's session we have did, in the last session we have completed amines now, so that's why I have collected questions from amines first, then we will slowly move to the aldehydes, ketones, carboxylic acids, okay. So in the upcoming sessions we will be having complete organic session also, okay. But as of now you please answer me, what will be your answer for this question? Yeah, so look at this, the question says consider a given reaction and the percentage yield of the products formed here. See, this is like multiple times asked question. See, whatever the questions I have collected for today's discussion, all of them are multiple times asked either in JEE, NEET or EAPCET exam, especially from JEE and NEET. See, aniline upon nitration we are getting ortho product as well as a para product. Along with this we are going to get a meta product. Generally what we know, aniline means it is an, like nitrogen here, it is an electron releasing group, activate the ring, therefore the electrophile here, nitration means here nitronium ion is a electrophile, right. So the electrophile should either go to ortho or para position. So we might expect A and C as our product, but what happens, you know, when this NH3, like NH2 is there now, so this NH2, like aniline is a base, right. So now what happens, we are treating with acid. So HNO3, H2SO4, both of them are acid now. First of all it get protonated, like sulfuric acid, let us say it is providing one H plus ion. So that H plus ion is taken by NH2 and converts into NH3 plus. See, now it is an electron withdrawing group it is becoming, right. Actually when we see it like this, it is a releasing group, ring activating. But if you see it like this, ring deactivating. So if it is a ring deactivating group, now electrophile in this case goes to meta position. That's why we are going to get ortho products along and also a meta product, ortho para and also a meta. Now they are asking about percentage of product here. So remember it is an experimentally determined value. So the 51% of a para product will get, what is the percentage of para product? 51, and 2% of ortho product, and remaining is how much? 47% of meta product will be formed. So now what is the order of these products? C, B, A. Where do we have this option? Yeah, so that's it. This is your answer for the discussion, okay. Hope you got how we are solving the question, right. Shruti in the comment box, good evening sir. Yes, good evening dear. So please follow the session, and if you have any confusion please let me know in the chat box, okay, right. Next question, the question says the given substrate treated with NaNO2 HCl. Yes, now tell me what is this A formed? See, if you have seen the JEE Mains 2026 session 1 questions, there are questions like diazotization questions, like what is happening, you can see aniline is treated with NaNO2. It will form diazonium chloride now, right. So just now in the amines chapter we have discussed in the class, as well as in the previous session, in the last session of amines in YouTube also we have discussed, okay. It will be forming N2 plus Cl minus, okay. This is SO3 sulfonic acid, remains as it is. This is our A. So now A is treated with like dimethyl aniline, okay. So it is easy, NN dimethyl aniline. See, the coupling reactions, if you remember, you might get the answer. See, what is our A here? I am writing A. Can I write it like this, SO3H, right. So diazonium chloride means N, triple bond N, so this nitrogen plus and chloride ion minus, like it's a salt. This is our A. Now this A is treated with what? N, CH3, CH3, okay, N and dimethyl aniline I can say. Okay, now see whether this is ring activating group or ring deactivating group. Activating group. and activates the ring by releasing the electrons at what positions? Ortho and para. Since these are bulky groups, electrophile will not come to the ortho. So it will be directed to the para position. Why? Because it is activating ring at ortho para, but there is no steric repulsions at para. So therefore electrophile can be added at the para position. So now these pi electrons will be donated to the nitrogen atom here. Okay, like this. Okay, and this will be going like this. So electrophilic substitution takes place. Finally, what is the product we are going to get? I am not writing complete mechanism, but I have given you the hint like what is happening here, right? Electrophilic substitution is taking place. Okay, so you are going to get, easily you can identify now what is the answer. Yeah, so it will be like N double bond N dimethyl groups, CH3 twice. That's it. So where do we have that kind of option? Right. So first option is your answer for the question. Okay, right. Those who are in the live session, if you are unable to see, yes, now you can take this screenshot. Yeah. Yeah. So the next question here. The next question here is again, aniline is treated with NaNO2 HCl. What is the product formed? Tell me first. What we know first, it is going to form like between this N and N, diazonium chloride will be formed. Like I mean CH2, yes, diazo bond is forming, so N2Cl minus. But there is no such options, right now. So now what will be the product then? See, we know whenever there is a diazonium chloride, I mean this is not a benzene, whenever there is a diazonium chloride formation, see this N2 is a stable gas, right now. See, N2 gas is stable. Normally if it is like N2, it is stable gas, but here you can see N2 plus is there, so it's not a stable, it's unstable. So now what happens, it will be upon keeping it for some time, it will goes out like N2 gas. So what is coming out here? N2 gas. See, if it is coming out N2 gas, the sigma bond electrons are also taken by nitrogen only, because nitrogen is more electronegative than carbon. So it will take, so it is creating what charge on carbon now? Yes, positive charge here. So cyclohexyl with CH2 positive, like this we got. Okay, so now, but this like this also there is no option right now. Okay, now what we can do, see, during the formation of N2, what are the things involving this oxygen and these hydrogens, like water molecule is formed now, right? So that water will be the nucleophile during the reaction now. Okay, see, this is a primary amine now, primary carbocation now. So if so if this proton is transferred to here, you are going to get a tertiary carbocation like this, right? So now this tertiary carbocation, now what is the nucleophile I am saying? Water. So how do you get this water, sir? Yes, we can get this N2, NH2 plus NO2 is reacting now. So during that time what is forming? Diazonium chloride, along with that water also form. So that water can act as nucleophile now. So you are going to get OH. So where do we have this option? First option, that's it. This is your answer for the question. Clear? Right. Next one. Yeah. So can you try this? Which of the following amine does not react with Hinsberg reagent? What is Hinsberg reagent? Tell me. In the last session also I discussed. Hinsberg reagent means. Yes, tell me. Hinsberg reagent means what? Benzene sulfonyl chloride. So what is Hinsberg reagent? See, benzene sulfonyl chloride. Okay, so this is called Hinsberg reagent. So Hinsberg reagent, using this Hinsberg reagent, we can able to Distinguish primary, secondary, tertiary amines. What is that? Primary, secondary, tertiary amines. Now what happens actually, see here, if we have a primary amine, let us say RNH2. Tell me, is this primary or secondary? Primary. Now NRH. This is? Yes. So now you can see there is lone pair here. So it means this chlorine and one hydrogen from here removed. So what is the product formed during the primary reaction? Primary amine reaction, you are going to get NHR. Okay, this is what the product formed. When it comes to secondary, what is the product formed? You check. SOONR. That's it. Okay. Now what makes the difference? Here we have an acidic proton. Sir, why you are saying this as an acidic proton? See, if I treat this with a base, what I am doing? The product formed will dissolve in basic alkali medium. Why? Because here proton is acidic. Why it is acidic means, if I remove this proton, whatever the negative charge we are getting, that will be stabilized by conjugation of these pi electrons. Okay. So that's why it is acidic proton. Okay. So now what we are going to get here? SOONR minus K plus. Okay. This is a dissolved salt. Means you need to remember that primary amines, upon reacting with Hinsberg reagent, benzene sulfonyl chloride, the product formed is there now, that will dissolve in the or soluble in the alkali medium, but the product formed from secondary amine upon reaction with Hinsberg reagent will not dissolve in the alkali medium, whereas a tertiary amine, if I take, that won't even react with the Hinsberg reagent. Okay, it means primary amine reacts, dissolves in alkali medium. Secondary amines react but does not dissolve. Okay, whereas tertiary amine, no reaction with this. Okay, it means we can classify them now, right? So now tell me, which of the following amine does not react with Hinsberg reagent? Yes, tell me. Triethyl amine, it means on nitrogen there are 3 ethyl groups. Okay, if 3 ethyl groups means it is a tertiary, so it won't react. Now what do we mean by neopentyl amine? So neopentane means something like this. Okay, so if I put one nitrogen here, NH2 group, this is neopentyl amine. Okay, similarly isopropyl amine is also primary. So diethyl amine means it's a secondary. So is it reacting with Hinsberg or not? Yes, it is reacting. Okay, only which one is not reacting? Third option, that's it. Next, tell me for this. So the given substrate treated with acetic anhydride. AC2O means what? AC2O means acetic anhydride. Okay, how we are getting? Just take 2 acetic acids, remove water molecule. You are going to get this acetic anhydride. So that is treated with our substrate like para-methyl aniline. Okay, now what happens? This acetyl group is in a CH3, CO, O, CO, CH3 is there. Now it will attacks here on the carbonyl group, this goes out. So that you are going to get A as NH, you can say this as acetanilide. What is this? Okay, CH3. Like this you will get. This is our A. So now A is treated with bromine, Br2. Yeah, it is treated with bromine in acetic acid. Okay, now what happens? See, it is very important reaction. There are 2 different things to be remembered here. When simple aniline is given, like NH2 is given, here NH2 is given, and they are asking us to add bromine water. What they are asking? Bromine water. This they will give bromine H2O. Now what you need to do is, this aniline is a highly activated ring by this nitrogen lone pairs. So these bromines will be added at ortho positions as well as para. So you are going to get a tri-substituted aniline. Br, 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 like this. Okay, but if I want to do bromination only at para position, how can it be possible? So it means since it is activating the ring, the reaction is more. But if I slow down or if I deactivate little bit with this nitrogen, so the reaction will slow down. So the electrophiles will be goes at ortho and para position in a controlled manner right now. So I need to do a controlled reaction. So for the controlling purpose, what I am doing is I am adding one electron withdrawing group on the NH2. So that is nothing but here one electron withdrawing group is added. Just check. It is withdrawing or releasing? Withdrawing. So now this lone pair electrons and nitrogen can be taken towards the ring side, means it is activating the ring, and also if you observe, it is taken by this side also, by this carbonyl group. It is deactivating also. Here completely activating, but here 50% activating, 50%, it means it is a controlled now, right now. So now if I do bromination, it will be now directed only to the ortho and para position. See, already para position is occupied by methyl. So there is no reaction at now para. So now this will be directed to the ortho position. Now tell me what is the product formed? NH, C double bond O, CH3. This is CH3. So Br will be here. Okay, like this it is forming. So this is our B. So do we have any answers like this? Check once. Yes. So you have a second option here. So do you got what are the steps we are following? Right, that's it. Okay, the next question here. Yeah, so look at this again, this is from JEE mains. Okay, yeah, tell me how can you do this? First of all, what they have mentioned, bromine in presence of sunlight. Where the reaction takes place? Bromine in presence of sunlight. Yes, see here, bromine in presence of sunlight. See, bromine with KOH only they mentioned, means that is half moon bromide reaction. But here they mentioned bromine in sunlight. So now that is happens, bromination takes place at this benzylic position. Free radical substitution takes place, and what happens, one of this proton is replaced by bromine, so that you are going to get HBr. So this is your first product. Okay, now it is treated with dilute KOH. Now what happens, tell me, dilute KOH means, yeah, see here you have lone pair electrons and nitrogen. Lone pair electrons and nitrogen. So what happens is these lone pairs will be attacks on this carbon. Bromine goes out. Okay, so now what is forming? What is there? CH3. I am writing CH3 this side, and here NH. Okay, how many hydrogens are there? 2 are there. Since next step is what? Dilute base. So base will abstract that proton and will give you NH. That's it. This is the final product. So do we have any product like this? Yes. Where it is? First option. So very simple now, but you need to know the steps. What this bromine in presence of sunlight happens. What happens? Bromine, always remember, if there is sunlight, you think about free radical generation. After that, whether it is substitution or addition, look at the substrate. So here there is nothing like addition, only substitution is possible at this benzylic position, right? So we will get a bromine here. The next NH2 lone pairs will be given to the carbon and bromine comes out. Okay, so here 2 hydrogens are there. Nitrogen makes 4 bonds. It means positive charge. Use this base to remove that proton. Okay, you will get the final product as A. Okay, right. Next question here. Look at this question again. This is also from JEE mains. The major product in the following reaction. So try to identify where this methyl iodide will be attacks the given substrate. There are many nitrogens. It's simple. You just use your the concept that you have learned. Huh? There is nothing like here ortho para we cannot say here. Okay, it depends, purely depends on, see, what is this, tell me, methyl iodide. So what happens? Methyl iodide means CH3I. So it means iodine will be removed as I minus, and here methyl carbocation will get. So this is the electrophile. Now what is the electrophile we have? CH3 plus. This is the electrophile, right? Okay, so now electrophile goes to which of these positions? It's very easy, ma. Where do we have more electron density? We need to check. Yes, where do we have more electron density? On which side we have? See, if you look at the option, methyl group in all options went to the nitrogen atom only. So it means you need to choose the nitrogen which is having more electron density. Right. See here, if I consider these are in conjugation like this, and all nitrogens are in conjugation. See here what I am doing, lone pair electrons are there, okay. So if these lone pairs are given here, so this comes here, okay, and this comes here, and this comes here, and this comes here, like that they are activating this nitrogen atom more effectively. Okay, it means you need to write the conjugations possible and check which nitrogen atom is having highest electron density, so that nitrogen atom will take the methyl carbocation, that electrophile. Okay, so it means methylation takes place at which position? So like this. Okay, so what is the concept here it is involved? Tell me. Looking for the electron density. Where do we have more electron density? That nitrogen will take that electrophile. Okay, right. Now yes, tell me, here I have given you one ring, okay, similar type of question. So on which nitrogen this electrophile will goes? On which nitrogens of these electrophile will be going? How do we consider that? See, first of all tell me, is this lone pairs involved in the conjugation or not? No, already pi bond is there now, so again conjugation won't possible there, lone pair conjugation. So if this is shifting this side, what you are saying? Yeah, if it is shifting this side, what happens? Yeah, but if you see in the reverse manner, if these lone pairs are given this side, pi bond will be shifting onto the nitrogen, right now. So now see, nitrogen is getting negative charge. So it means electrophile goes to which nitrogen? Top one or this one? The top one here. Okay. So it means you can simply add like this, a positive charge. Okay. So this is how, like that is how, like by looking at their electron density we need to add. Okay. Right. So how do we get complete ideas? Or means you just need to practice some questions. Okay. So similar model questions you just practice, then you will get idea. Okay. Now look at this, one of the very important model question, ma, this is again. First of all, given substrate if you observe, there is alkene and the next 1, 2, like this we have, and what they are asking us to add? Iodine. Iodine followed by Na, like NaHCO3 is there, followed by here pyridine is there under heating condition. Okay, it's very simple. The steps to be followed here are like this. See, iodination, like do you remember bromination of alkenes, like that we have studied. So it means this iodine will react with the pi bond first. Okay, so how it will be by following haloammonium ion mechanism. See, OH. See here, between iodine repulsions will be there due to the lone pairs. Okay, so now what happens, let us say one iodine is taking the bond. Now you are going to create a positive charge on the other iodine, right? So now this ring opening takes place like this. See, because why this is coming this side? Because iodine is getting positive charge. Okay, let us say this bond is coming this side. It means one of the carbon will get a positive charge because it is losing. So to that positively charged carbon, iodine will give its lone pair. It means you are making a iodine bond like this. 3-membered ring is formed. Okay, because one iodide ion is going out. So this is what the intermediate like fragment is formed. After that, what they have given? Base NaHCO3. So that NaHCO3, HCO3 minus is there now. So that will take the proton from here. If it is taking proton, what you are going to get? So write that. Like this I am writing. Do you have any issues? No. Like this. Okay. So just I changed their places. Okay. So now what happens? Here this 3-membered ring is unstable now. So the O minus will be the nucleophile now. So where it will attack? Either on this carbon or this carbon. Just count what is the ring size we are going to get when O minus is attacking. See, 1, 2, 3, 4, 5. If it is attacking here, we are going to get a 5. If it is attacking here, 4. That 4 is unstable. So make it 5-membered. So you can add here like this. So what it is giving you? O attacking here, so O like this. So iodine will be okay. Up to here it is clear. Yeah, we got a 5-membered ring if you observe. Okay, and after this, what is the next thing they have mentioned? Pyridine. So pyridine. See, do we have this kind of options? No option like this. Okay, so it means something we are missing. It means here the pyridine is a base now. Okay, so pyridine will abstract a proton, so that we are making a double bond. So which hydrogen is acidic? Tell me here. Which hydrogen is acidic? Yes, carbonyl group alpha hydrogens are acidic. We know this now? Yeah, because aldol condensation, all this we have studied. So there we got to know alpha hydrogen of carbonyl group is acidic. So that acidic proton is removed. Okay, so that an elimination like alpha beta elimination is taking place. Okay, the final product will be this one. Okay, that's it. Do we have this kind of option? Yes, third option is your perfect answer for the question. Okay, yes. Let's move forward. Give me your answer for this. Try it once. Yes, tell me your answer. Write the structure of hex 3 ionol. One, two, three, 4, 5, 6. Okay, so 3 position, third position. Okay, ion. Okay, and first position aldehyde. That's it. So 1, 2, 3, 4, 5, 6. Okay, so hex 3 ionol. Perfect. Treated with NaBH4. Now what happens with NaBH4? NaBH4 is a reducing agent. So now what it will do? Where it is added?
To the oxygen.
That aldehydes converts into alcohols. Okay, triple bond remains as it is. So 1, 2, 6 now, 1, 2, 3, 4, 5, 6, OH, okay, this is hydrogen, a new hydrogen is added here, okay, 1, 2, 3, so triple bond as it is. Next one, it is treated with what? PBr3. Now PBr3, what it will do?
OH is
Yes, sir. OH is replaced by Br, like PCl3, PBr3 we studied now, right. So that OH group is substituted by bromine by SN2 mechanism. Okay. So 1, 2, 3. Okay. So here I am writing Br. Okay. So 1, 2, 3, 4, 5, 6. Okay. Perfectly fine. Next it is treated with what? Magnesium. Now what happens? Alkyl halide with treating with Mg. What happens? It will forms MgBr, like Grignard reagent is formed. So simply I am writing here same product. Okay. So writing same thing. So here I should write MgBr. That's it. Okay. Next that is treating with CO2. So CO2 is an electrophile. Okay. Our Grignard reagent here, carbon with minus charge, will be attacks on this carbon. So you are going to get what? Carboxylic acid. See, 1, 2, 3, 4, 5, 6. This is a new carbon, 7th carbon. 7. Okay. So it means OH. So 1, 2, 3, 4, 5, 6, 7. That's it. So where do we have? 1, 2, 3, 4. Yes, 4, 5, 6, 7. So perfectly answer 4th one. Okay. Right. This is how we need to do. Someone is asking, sir, is it necessary to learn cyclic compounds for AP EAPCET? That type of questions were never asked. See, it's not about whether they asked or not. Just follow the syllabus first, okay? Because this time a new person will come with the same question, because he will also think like you, like yeah, we haven't asked any time previously from this particular concepts, so let's ask this time. Okay, so they may think like that. Okay, there is some chances, right? So it's better to learn all the IUPAC nomenclature, because it's a very fundamental thing. Okay, so IUPAC nomenclature of cyclic compounds you should not skip. You should focus on it. Okay, so it's very simple. You first learn normal chain IUPAC name. The next go through the cyclic compounds. That's it. Yeah, tell me what is your answer for this? Yeah, what is your answer for this? The given compound is treated with chromic oxide, CrO3. So it is an oxidizing agent. What is it? Oxidizing agent. Oxidizes alcohols. If it is a primary alcohol, gives you carboxylic acid. If it is a secondary, gives you ketones. Tertiary, no reaction. Tertiary, no reaction. Remember this. Yes, tell me. So there are two alcoholic sites, but will both converts into oxidized form? No. See, this is a phenolic alcohol now, phenolic OH now, so it will not be changed. Okay, this one will be converting into carboxylic acid, because it's a primary alcohol. So you are going to get OH here as it is. The next, here we have OH now, convert into carboxylic acid like this. Perfectly fine. Okay, when it happens, when you are treating this with CrO3, chromic oxide. Okay, up to here it is clear. Now they have treated this with SOCl2, thionyl chloride. What it will do? Yes, it will provide chlorine. So that chlorine, this OH is replaced by chlorine. Okay, so that you are going to get acyl halide type of product. Okay, acid halide, OCl. Okay, up to here second step also done. Next third step they are saying us to heat it. Now what happens, heat it means, see, all of them are cyclic rings are there, but there is a open side. So now what happens, tell me, See, what type of group the product here we have? See, 1, 2, 3. So, what type of group it is? Electron rich group or electron deficient group? Deficient group, right now. So, again, what about this OH group? Like, forgot about this, it is a phenol type of ring now. So, what it will do? It will activate or deactivate the ring. At what positions it will activate? Ortho and para. See, already if I do this as ortho, already there is a combination. So, already some groups are there, repulsions will be there. So, we can make a reaction at this from this para. So, what I am saying, it will activate the ring at this para position with negative charge. So, now this negative charge can attack on this side. Yes or no? So, now chloride ion comes out, you are going to get your final product. See, I am not giving complete mechanistic steps because already we did in the class. Okay, so you can write it as OH group here, okay, and with respect to OH, see 1, 2, 3, 4, 5. So 1, 2, 3, sorry. See 1, 2, 3, 4, 5. Just check, is this the ring formed? Yes. So now if you want, you can number it like this 1, 2, 3, 4 and this is 5. So 1, 2, 3, 4, this is 5. On fourth carbon we have a, that's it. So where do we have such option? Check, where do we have? This is chlorine, no, this is removed. Okay, so you can see para to that OH group should be there. Para to this OH group is there. Perfectly, which option is perfect here? Second option. So this is your perfect answer. Okay, is this clear? Clear? Next. Yeah. So again, look at this. This is from NEET. Do not get stressed when you are seeing that many transformations. Just go through it. What is happening in the question? What is our X here they mentioned? They mentioned just the formula they have mentioned. X as like A, X, Y, Z they are saying. So they are saying X as C2H6O. Okay. So that is treated with copper metal. It is giving you A. So now A is forming silver mirror. It means what is the silver mirror? Yes, it can be aldehyde or ketone. But with 2 carbons we won't get ketone. Definitely it should be a aldehyde. So A should be an aldehyde. Okay, sorry, silver mirror is given only by aldehydes now. Yes, so it is aldehyde. Okay, so now with 2 carbons try to make one aldehyde with this formula. CH3 COH. If I write it like this, this is aldehyde. This is aldehyde. This is our A. Okay. Before getting this aldehyde, it might be some other compound. What is that other compound? Is C2H6. Yes. So copper metalite is doing oxidation of primary alcohols to aldehydes. So now what is our primary alcohol here? CH3 CH2OH. So this is our X compound, ethanol. Upon oxidation using copper metal, you are getting aldehyde. So this is our A. You got X, you got A. Okay. Now you can add Tollens reagent to get silver mirror. That is carboxylic acid here they are formed, but they are not asking about that. Now if you see, they are treating this aldehyde with base under heating condition. What is this reaction? See, acetaldehyde CH3 COH treating with base like NaOH under heating condition. First, second. What is this? What we have here? Alpha hydrogens are there. Base is there. What is that famous reaction we have? Aldol condensation, no? Yes or no? Like, see, they won't mention the dilute NaOH constant. See, they will mention like OH minus, heating condition. Yes, there is alpha hydrogens means with base definitely aldol reaction takes place. Okay, if there is no alpha hydrogens, you may consider it as canizaru. Okay, so here alpha hydrogens are there, so what we are going to get? So take these 2 moles, yeah, so CH3, C, O I am writing, plus CH2H, COH. Okay, so acetaldehyde 2 moles, so just remove water, what we are going to get? CH3, CH, double bond CH, COH. What is the name of this compound? This is Y. What is the name of this compound? 1, 2, 3, 4. So but 2 in all. Okay, so this is our Y. Now see, aldehydes and ketones are electrophilic centers or nucleophilic? The carbon of the carbonyl group is electrophilic. Now that electrophilic compounds are treated with this compound. This is called semicarbazine or semicarbazide. What is that? When I am explaining aldehydes, I told you about these semicarbazines. It will form semicarbazones like that. Hydrazines, hydrazones. Yeah. So now let us say 1, 2, 3. Which nitrogen will react? Tell me. This discussion also we did in the class. Which of this nitrogen will react? This first one. Yes, because these lone pair electrons present on the nitrogen here are in conjugation with this electron withdrawing group. So they won't be much available to donate to that carbonyl group carbon. But here these are not in conjugation. Yes, easily attack on this carbonyl group carbon, right? So the product formed should be called as a semicarbazone. What is that? So Z is semicarbazone. Yes. Now tell me. So semicarbazone is nothing but remove oxygen and this 2 hydrogen as water. You are making a carbon nitrogen double bond. That is called as semicarbazone. So now tell me, what are A, B, C, D? I mean, A is what? Ethanol. Ethanol or ethanol? What is it? This A, aldehyde now. AL, but there is no AL here. Acetaldehyde they are saying. So acetaldehyde is fine. Okay. A is ethanol. Yes, this is also perfect. Yeah. Next, X is what? Ethyl alcohol, ethanol. Okay. So X here only we have in this option. Yes. So only here we have, from this also we can directly say, but we can also conclude with butylenol. And what is this product from? So it is D. Okay. So it's a really good question, no? It is a time consuming question for those who haven't practiced or those who have no idea on this type of chemical reactions. So try to explore to the maximum number of different questions or this kind of transformations. If you see like reaction series questions, you will feel more confident if you practice this kind of questions, because it includes multiple concepts. See, oxidation of alcohols involved, Tollens chemical properties of aldehydes involved like Tollens reagent, okay, and then next chemical reaction is involved like aldol condensation is involved. Next its reactivity. Okay, all this is very interesting. Okay, now tell me list 1, list 2, try to match them. Huh? Cyanohydrin, it means list 1, list 2 they are saying. We are studying about ketones and aldehydes now. Let us consider a ketone or aldehyde carbonyl group is there. To that you are adding this, what are the respective products formed? That is what they are asking. If I add alcohol, what we are going to get for a carbonyl compound? Read this. So what we are going to get? Alcohol to the carbonyl compound. Like if it is aldehyde, we are going to get either hemiacetal, next acetal. If it is a ketone, we are going to get hemiketol, ketone. So B3. Okay. Then next, if I am adding HCN, cyanohydrin. So 4A. Next, hydroxylamine. Hydroxylamine gives oxines. Okay, and here alkyl amines if we add, we are going to get imines, that is also called as Schiff's base. So which is our option? A4, B3, C2, D1, so option 1. Okay, like this. Next, tell me this one. See, all the questions we have collected are PYQs only. See, all these are your NEET questions. Yes, tell me. The product formed by the reaction of an aldehyde with a primary amine. Just now, in the previous question I told you. Aldehyde with a primary amine. Just see man here, amine reacting with carbonyl compound. Shift base also called as amines. So let me show you the reaction. See, this is a carbonyl compound NH2R. So what I am saying, remove water. What is remaining? NR. So CN. So this kind of compound. See, normally C and N, like the single bond is there, means what you are saying? Amines. Like CH3 NH2 is there. What you are saying it as? Methylamine. But if there is a double bond between carbon and nitrogen, you should call it as imines. What is that? Imine. Imines are also called as Schiff's base. Okay, very important in organic reactions. Okay, remember that name. Next, this reaction you read once. Which of the following reagent would distinguish cis cyclopenta 1, 2 diol from its trans isomer? Yeah. So first write the structure first. Do not give your direct answers. First write the structure first. Cyclopenta 1, 2 diol, but it is a cis form. It means both OH groups should be either above the plane or below the plane. So this is cis form. Trans form means above the plane, below the plane. So now how can we distinguish them? What is the best suitable reagent here we have for that? Yeah, see MnO2, these are oxidizing agents. Okay, ozone, no use. But here, if I take acetone, what happens, you know? Acetone means what is the structure? CH3O. So now see this hydrogen, oxygen and hydrogen removing like a water. Now what is the resulting species we will get? Like see oxygen, carbon, CH3, CH, like this. Okay, so we got a ring again right now. See, in order to form this kind of 5-membered ring or some ring, both groups should be from same plane. If one is above the plane, one is below the plane, means almost like is one above below. Is that ring formation takes place? No. So will it be possible with the trans one? Because one is above, one is below. But cis means both are in the same plane. So here it is possible. So we can separate or distinguish cis and trans isomer using something like acetone by making a ring. Okay, so this kind of some questions will be there. We might have not studied, but you try to use the concept that you have learned. See, this is alcohol means there is nucleophilic centers. This is electrophilic center. Say, tell me first of all, it is ketol or acetal or what it is? Hemiacetal, hemiketal, what is it? First of all, ketone ma. Ketone forms either hemiketal or ketol. Yes, tell me now what it is. Ketol form. Yes, do we studied about ketols, hemiketals, acetals, hemiacetals or not? Yes, this is nothing but formation of ketol only. Okay, so you have studied, but you need to like interlink it or connect it to the given question the best way possible. Okay, right. Tell me for this question you can easily answer. Predict the products given in the reaction. First of all, look what type of reaction taking place there. Given aldehyde treating with KOH. With KOH aldehyde, what type of reactions we have? Observe what we have. Do we have any alpha hydrogens? No alpha hydrogens means might be Cannizzaro, right? Yeah, look at the products now. In Cannizzaro reaction, what type of products we got? One is oxidized and another one is reduced. That is carboxylic acid, alcohol. Yeah, now identify. Now what happens? What is the alcohol? I mean carboxylic acid formed from here, oxidized product. Chlorine, do not disturb it. What happens here? CO, O minus, K plus. This is alcohol formed. Carboxylic acid form, oxidized one. Reduction product is what? Cl, CH2, OH. So where do we have such option? Option D is your perfect answer. You might be having now, sir, why this chlorine is not getting disturbed? Yes, it won't get disturbed because see 1, 2, 3, meta position only. See, this chlorine is in conjugation with the pi electrons of ring. So we know aryl halides do not involve. They are inert. They are not labile. Inert means what? They won't show any reaction, chemical reactions at normal conditions. Okay, high temperatures are required for aromatic substitution reactions. Okay, remember. Next. Yes, try this. Try this and answer me. Yes, you can do this. So tell me what to do. Alkenes with HBr. Which type of addition? First step is what? This one, styrene is given. Yes, Markovnikov rule. C double bond CH2, CH, phenyl group is there, pH. Yeah. Now what happens?
Br to the second.
HBr we need to add. So unsymmetrical alkene and unsymmetrical reagent. So unsymmetrical reagent, negative part will goes to and positive part like H plus goes to which carbon?
First carbon.
This terminal carbon. So positive charge created here, stable carbocation, there bromine attacks. Okay, so pH, CH, CH3, Br. This is the one over. Next, magnesium, alkyl halide with, yeah, see, this is the second or third question adding alkyl halides with magnesium, creating Grignard reagents, right? So pH, CH, CH3, Mg, Br. Then next they are asking us to add CO2. Yes, in the previous question also we have seen CO2 addition. Yeah, what happens? Electrophile will get a carboxylic acid. So pH, CH, CH3, COOH. This is treated with thionyl chloride. Again similar step.
OH is replaced by.
Yes, OH is replaced by chlorine. So it means pH, CH, CH3, CO, Cl. okay, and treated with methylamine. So now what happens, methylamine will replaces this chlorine, okay. So you can check the options, where do we have, see, because methylamine means NH2CH3, lone pair electrons here will attack on this carbonyl group carbon, okay, like this chlorine comes out finally, okay. So we'll get PH, CH, CH3, CO, NH, CH3. So where do we have such option? Second option. So this is our B, final product B, and this is A, carboxylic acid that we got here. pH, once check, once again. No, not the second option. Once again look back, yeah, third option you can see, because pH, CH, CH3, COOH, okay, it should be like this. So third option is your perfect answer. Yeah, see, we got perfect answers, but choosing the right one is mandatory thing here. After doing this much hard work, if you are choosing a wrong, means everything gone, okay. So which is the perfect one here? Third one, that's it, okay, right. The next here, yeah, so I will be providing few more questions, okay, you just try them. If you are unable to answer, you just watch the PYQ session that I have made, aldehydes, ketones, carboxylic acid, in the previous chapter, okay, when I discussed the last session of aldehydes, there I have discussed answer for them. You please watch it and make clear-cut understanding of these concepts, okay. So thanks for watching, stay connected with our NEET World channel, thank you. Okay.